Hello, this is Tim Farley, student number 19335376, presenting assignment 3 for real-time rendering. So yeah, the focus of this assignment was on bump and normal mapping. For development, I did pretty much everything almost purely in GLSL using the shader toy extension for VS Code. So yeah, the first shader here, or well, the first thing I have here to show you is a sphere with a rotating light source in this the similar environment to the one we had for assignment 2. So yeah, I've created two shaders, one for a sphere and another for a cube, to demonstrate these techniques. So we'll start with the cube here, or sorry, the sphere, which combines both bump and normal mapping for enhanced surface detail. So yeah, the scene consists of a ray march sphere with a rotating light source. As you can see, the light source is rotating around the sphere gradually. Yeah, there you go. You can see it there now. So yeah, so the lighting includes ambient, diffuse, and specular components. Same for the textures, with additional rim lighting for enhanced realism. You can let me adjust the light orbit speed just to show you um, how it changes. So I'll just make it really slow, or we'll make it really fast. Not really fast, but faster. Yeah, that's a bit better. So yeah, first we'll have a look at the normal mapping implementation. So normal mapping is implemented using a separate texture channel. So you can just watch what happens when I change the normal strength down to a very low number. You'll watch it become very smooth. Yeah, you can see there. And you can watch what happens when I bring it back up very high. Yeah, you can see all the texture there. So I'll bring this back down to a medium value. So yeah, as you can see, this enhanced the perceived surface detail by perturbing the surface normals according to our normal map. So yeah, we might now look at the bump mapping effect. So bump mapping adds another layer of detail through height-based normal perturbation. So let's modify the bump strength. Let's bring this down to 0.05. So you'll notice just a slight detail, or rather, slightly smoother surface displacement effects. It'll probably become more noticeable when I bring it back up. So yeah, as you can see, there's more pronounced surface displacement effects. The combination of both normal and bump mapping provides more convincing surface details than either technique alone. So yeah, the shader includes several lighting parameters that we can adjust. So you can watch as I change the specular power. Let's double this, become super bright. Yeah. This creates kind of just sharper reflections. I'll bring it back down to, let's say, a much lower number here. Yeah. And you can see my rim strength parameter adds edge highlighting, so it's really quite sensitive. So if I was to change this up in order of magnitude, yep, you can see, but we'll bring it back down. Let's bring it down even lower. So down 20x. So yeah, that's it for this slide. I'll show you quickly also the cube implementation. We made the cube rotate here. The key challenge, honestly, was just getting the textures to stick directly to the cube. We did this, so main challenge here was properly mapping UV mapping for the cube faces, which required careful handling of texture coordinates in object space. As you can see, it's sticking together to it very nicely, and I'll just turn down the highlight rim strength. And yeah, this has all the same features. Probably the easiest one for me to demonstrate this is to bring down the normal strength, make it super smooth, and let's bring it back up high. So yeah, there you go. So yeah, to conclude, this implementation demonstrates the power of combining normal and bump mapping for enhanced surface detail. The adjustable parameters allow for fine-tuning of the visual effects, while the dynamic lighting and rotation help showcase the 3D nature of the surface modifications. All code is written in GLSL, utilizing ray marching for rendering and custom functions for texture mapping and lighting calculations. So yeah, thank you.